Hello, my dear friend, and welcome to Knowledge Before Sleep. Tonight, as the lights outside begin to dim and the space around you grows quiet, I want to invite you on a distant journey with me. Let your body relax. Find a comfortable position in your soft bed and take a deep breath. We won't be traveling on our feet, but with our minds, crossing millions of kilometers of dark space to reach a planet of melancholy yet mesmerizing red Mars. That planet, Earth's close neighbor, has long been the inspiration for countless stories. But behind the quiet facade of dusty deserts and harsh, dry winds, Mars hides a sorrowful secret of a glorious lost past. Once, it wasn't the frozen graveyard it is today. Once, the skies of Mars were also a deep blue, and ocean waves whispered as they lapped against sandy shores. Why did a world so full of life become so desolate? Tonight, we will find the answer together, gently and slowly, just like the rhythm of your breath right now. Close your eyes and let the story of Mars guide you into a deep sleep. As you picture Mars in your mind right now, the first image that comes to mind is likely a vibrant red, like the color of an old brick or the rust on ancient ships. Mars, as seen through the lenses of modern spacecraft, is a planet of harsh extremes. It is a world where silence reigns supreme, broken only occasionally by the hiss of colossal dust devils, kilometers high, sweeping across vast plains. If you could stand on the surface of Mars right now, you would find yourself in a colossal desert, larger than any on Earth. Beneath your feet isn't fine beach sand, but a layer of dust as fine as powder, rich in iron oxide, the very substance that gives the planet its signature red hue. The sky here isn't the gentle blue of our home. During the day, the Martian sky takes on a pale pink or a hazy butterscotch yellow due to suspended dust. And when dusk falls, a strange phenomenon occurs. Instead of the fiery red of an earthly sunset, the sunset on Mars is an ethereal blue, a hauntingly solitary beauty. The atmosphere of Mars today is incredibly thin, almost unbelievably so. Compared to Earth, the atmospheric density at the Martian surface is less than 1% of the density at sea level on our planet. Its main component is carbon dioxide, making up about 95%. There's a little nitrogen, some argon, and only minuscule traces of oxygen and water vapor. You wouldn't be able to breathe here, and the air pressure is so low that without a specialized suit, the liquids in your body would instantly boil and vaporize. The temperature on Mars is a tale of bitter cold. Located about 70 million kilometers farther from the Sun than Earth, Mars receives significantly less energy. On the warmest summer day, at the Martian equator, the temperature might reach about 20 degrees Celsius, a rather pleasant figure, but as soon as the sun sets, the temperature plummets, dropping to minus 80 degrees Celsius, or even as low as minus 125 degrees Celsius at the poles. This drastic temperature swing is because the thin atmosphere is incapable of retaining the sun's heat to warm the planet through the night. At both of Mars's poles, there are vast, white, permanent ice caps shimmering in the faint sunlight. But don't let their appearance fool you. Most of this ice is not the water ice we're familiar with, but dry ice, carbon dioxide, frozen solid by the extreme cold. In winter, the Martian atmosphere gets so cold that a quarter of the carbon dioxide in the air freezes and falls to the ground like dry snowflakes, causing the polar caps to expand. When summer arrives, they sublimate directly back into gas, creating powerful winds that sweep across the planet. Although it may seem tranquil, the terrain of Mars tells stories of a violent era. There, you'll find Olympus Mons, the largest volcano in the entire solar system. It's 3 times the height of our Mount Everest, and so vast that if you stood at its base, you couldn't even see the summit, as it would be hidden beyond the planet's curve. Next to it is Valles Marineris, a colossal canyon system over 4,000 kilometers long and up to 7 kilometers deep. If placed on a map of Earth, it would stretch from the east coast to the west coast of the United States. These geological wonders are now dormant, with no more molten lava flows, no more powerful tectonic movements. Mars is like a museum of time, where everything seems to be frozen in an eternal stillness. However, it is in this desolation that scientists have found strange clues. They see dry riverbeds strewn with pebbles, plains that look like the remnants of a great flood, and minerals that could only have formed in the presence of liquid water. This evidence raises a huge question. What happened? How could a planet that once had rushing rivers, deep oceans, and a thick, warming atmosphere become the cold mummy it is today? The story of Mars's decline was not a sudden accident, but a process that spanned billions of years. It was an uneven battle between a small planet and the harshness of outer space. Mars once had all the necessary conditions to become a second Earth, but destiny took a different turn. As we drift deeper into sleep, let's imagine we are turning back the wheel of time, returning to a point 4 billion years ago, to witness a very different Mars, a Mars that was blue and full of hope. Chapter 1 closes with the image of a crimson Mars against the black night. We have seen its true face in the present, a dusty, cold, and lifeless desert. But do not be saddened yet, for in the next chapter, we will join the explorers to find the scars of time, the powerful evidence that water truly once existed here. In the silence of the night, as your mind begins to drift away from the worries of a long day, let me take you back in time. We won't stop at the Mars of today, a dry and dusty planet, but will journey back about 4 billion years. Back then, Mars was not a sorrowful red. Instead, looking from space, you might have seen a blue planet with wisps of white clouds drifting by, looking just like Earth's twin. How do we know this? Scientists aren't just speculating. The evidence of water on Mars is etched clearly and magnificently upon its very surface, like scars of time that tell of a vibrant youth. The first traces that astonished humanity came from the visit of the Mariner 9 spacecraft in 1971. When the global dust storm subsided, this small spacecraft sent back images that completely changed our understanding. Intricate networks of valleys that looked exactly like dried-up riverbeds. Just imagine how vast these ancient rivers were. There were valley systems stretching for more than 2,000 kilometers, with gentle, meandering curves and tributaries flowing into the main channel, just like the Amazon or Mekong rivers on Earth. To carve out riverbeds hundreds of meters wide and deep, water must have flowed persistently for millions of years, not just in fleeting flash floods. This proves that, in the past, Mars's atmosphere must have been thick enough and warm enough to keep water in a liquid state on its surface, something that seems impossible for the Mars of today. One of the most convincing pieces of evidence is the presence of river deltas. Picture where a great river flows into a sea or a giant lake. There, the current slows down and deposits particles of mud, sand, and gravel, forming a fertile, fan-shaped landmass. On Mars, in a place called the Jezero crater, NASA's Perseverance rover found just such a perfect delta. Through its sharp lenses, we can clearly see layers of sediment stacked on top of each other, evidence of a time when this place was a deep lake, fed by a rushing river flowing down from the highlands. The smooth, rounded pebbles scattered across the ancient lake bed are undeniable proof. Only a continuous flow of water could have worn down the sharp edges of rocks into such gentle shapes. The evidence isn't just geographical. The robotic explorers have also acted as dedicated chemists. The Opportunity rover, during its historic journey, discovered tiny spheres that scientists nicknamed blueberries. In reality, they are round concretions of iron oxide, which could only have formed in mineral-rich liquid water. Similarly, when the Curiosity rover drilled deep into the rock layers of Gale crater, it found clay minerals. Clay is a special material. It's the result of rock weathering and altering after being in contact with water for a very long time. The presence of clay and sulfate salts in ancient rock layers indicates that water on Mars not only existed, but it was also fresh and had a neutral pH. It might have even been drinkable had we been there billions of years ago. Let's journey even farther north on this planet. There lies a vast, flat plain, significantly lower than the rest of Mars. Many scientists believe this plain was once the floor of a colossal ocean that covered up to a third of the red planet's surface. This ocean could have been thousands of meters deep, holding an enormous amount of water, enough to create waves that lapped against the cliffs of the southern highlands. Imagine a sunset on ancient Mars, as the sun's light reflected on the vast ocean, creating shimmering bands of light in the warm, humid air. It's a magnificent vista that today exists only in silent layers of rock. NASA's Mars Reconnaissance Orbiter mission, with its advanced scanning instruments, has also discovered traces of terrifying megafloods. There are landscapes torn apart by water flows thousands of times greater than the Mississippi River, which occurred when enormous underground pockets of water suddenly burst or when ice melted abruptly due to volcanic activity. These floods swept across the surface of Mars, carving deep channels and carrying house-sized boulders for hundreds of kilometers. All this evidence paints a complete picture of a world teeming with life. Water was everywhere, in tranquil lakes, in raging rivers, and in vast open oceans. The existence of liquid water means that Mars once had a water cycle similar to Earth's. Water evaporated into clouds, rain fell on mountains and forests, though we don't yet know if there were forests, and flowed back to the sea. But as we stand amidst this powerful evidence, a lingering sadness emerges. Why did it all disappear? Why did the rivers stop flowing and the oceans dry up, leaving behind a planet of nothing but dust? It is one of the greatest mysteries in astronomy, and it is also the focus of the journey we are on. The scars on the surface of Mars are a reminder of just how fragile life and its ideal conditions can be in the face of the universe's power. As we conclude this chapter, we have confirmed a crucial fact. Mars was once a planet of water. The riverbeds, the deltas, and the specific minerals have told us a story of a brilliant past. We have seen concrete images of smooth pebbles and vast plains that were once seabeds. But to understand why that paradise collapsed, we need to look deeper into the very structure of the planet itself, starting with its formation in the dawn of the solar system. A pleasant feeling is now spreading, guiding you into a state of absolute relaxation. The story of the ancient waters has come to a close, making way for the next chapter on the beginning of Mars. Together, we will discover how this planet was born and why its size played such a crucial role in its later, sorrowful fate. Let your mind continue to drift freely into the infinite expanse of space, crossing the barriers of time to return to a moment so distant our minds can barely conceive of it. That was about 4.6 billion years ago, when our solar system had not yet taken shape, but was merely a giant cloud of dust and gas, spinning quietly in the darkness of the galaxy. That cloud, which scientists call the solar nebula, held the seeds of everything we know today, from the warmth of the sun to the mountain ranges on Earth, and of course, the lost oceans of Mars. In that stillness, a grand event occurred. A part of the giant gas cloud began to collapse under its own weight, perhaps triggered by the shockwave from a nearby supernova. As the cloud shrank, it began to spin faster, like an ice skater pulling her arms in to speed up her rotation. At the center, matter compressed to form a giant ball of fire that was the infant Sunday. Around the sun, the remaining material flattened out into a spinning disk, made of dust, rock, and gases like hydrogen and helium. This was the stage where Mars and the other planets were about to be born. In that dusty disk, tiny specks of dust began to collide and stick together. At first, they were just small grains of sand. Then they gradually grew into boulders, and then into massive objects kilometers wide that we call planetesimals. Mars began its life in the same way. At a distance of about 230 million kilometers from the Sun, enormous blocks of rock collided with terrifying force, generating so much heat that it melted everything. Mars, at that time, was a molten sphere, glowing red like a giant ember in the vast blackness of space. The formation of Mars happened incredibly fast. According to the latest studies, it took only about 5 to 10 million years for the planet to reach its current size. This is a very short period compared to the hundreds of millions of years Earth needed to fully form. This rapid formation endowed Mars with a fateful characteristic. It was like a planetary embryo that never fully developed. Mars stopped growing at about half the size of Earth, with a mass of only about 10% of our planet's. This modest size, as we will see in later chapters, was the Achilles heel that prevented Mars from protecting its atmosphere and its water. In that dawn, Mars was in a very favorable position, right on the edge of the habitable zone, the region where the temperature from the Sun is just right for water to exist in liquid form. As the planet's surface began to cool, a solid rocky crust formed, enclosing a molten iron and nickel core within. Intense volcanic activity began, spewing out large amounts of gases from the planet's interior. These were carbon dioxide, nitrogen, and water vapor. This layer of gas enveloped the planet, creating its first primordial atmosphere. At that time, this atmosphere was very dense, creating enough pressure and a strong greenhouse effect to keep the surface temperature of Mars consistently warm. Water, the source of life, also began to find its way to Mars. In addition to the water vapor released by volcanoes, the young planet was also visited by guests from the outer solar system. These were water-rich asteroids and comets that crashed into Mars's surface, releasing the enormous amounts of water they carried. Over millions of years, the first rains began to fall on the red planet. Rainwater flowed down the slopes of volcanoes, collecting in low-lying areas to form the first lakes and oceans. The Martian sky, then, was likely brilliant with thick clouds, and the air was heavy with moisture. Try to picture the scene on Mars at that time. It was a world full of life and change. The Sun, though younger, was far more violent, frequently emitting powerful solar winds. However, in its early days, Mars had a solid protective shield. Thanks to the molten core still spinning inside, the planet generated a strong magnetic field, which surrounded it like a protective cocoon, preventing charged particles from the Sun from penetrating and destroying the atmosphere. Mars back then was truly a potential paradise, a planet brimming with the hope of nurturing life. The beginning of Mars was almost unbelievably perfect. It had a warm temperature, a thick atmosphere, liquid water, and a protective magnetic field. If you could have stood there 4 billion years ago, you would have seen a world very similar to our home, Earth. And yet, why didn't everything continue to develop in that direction? Why did this planet stop maturing and then gradually lose it all? The answer lies deep within the planet, in its very heart. The small size of Mars, which it was endowed with from the dawn of the solar system, was the root of all its troubles. A smaller object cools down faster, just as a small cup of tea cools faster than a large pot of water. And as the core of Mars began to cool, its protective shield began to crack. We close this chapter with the image of a young, vibrant, and water-filled Mars. It was the golden age of the red planet, a period when all conditions seemed to be set for a glorious future, but the harsh laws of cosmic physics were already at work. To understand where this decline began, in the next chapter, we will take a journey through the layers of rock and soil to explore the heart of a planet where the secret of the life and death of Mars's magnetic field is kept. Your breath has now become so light, rhythmic, with each part of the story. Just let yourself sink into this piece as we prepare to enter a new chapter of cosmic history. Let your mind settle, leaving behind the images of vast rivers or oceans on the surface, to join me on a journey deep into the planet's interior. We will look past the red dust and dry cliffs, and instead go deep inside to where the heart of Mars is held. It is here, in this profound depth, that the fate of an entire planet was decided billions of years ago. Imagine Mars as a giant egg, gradually cooling after being taken out of the universe's oven. In its early days, when the planet was still molten, a miraculous process called differentiation took place. The heaviest elements, especially iron and nickel, were pulled by gravity and sank toward the planet's core. Meanwhile, lighter elements like silicon and oxygen floated to the top, like the scum on a bowl of soup, to later cool and crystallize into the hard, rocky crust our rovers are rolling across today. At the center of Mars is a massive core, about 1,500 to 2,000 kilometers wide. Scientists, through NASA's InSight lander mission, a modern geology lab that landed on Mars in 2018, have listened to the heartbeats from deep within the planet through its seismic tremors. Thanks to this, we know that Mars's core is not just a quiet block of metal. In the dawn of the planet, this core was a brilliant, fiercely swirling sea of liquid fire. Why is a spinning core so important? Picture a small dynamo on a bicycle. When you pedal, the wheel's rotation spins a magnetic core inside a coil, generating an electric current that lights up the bulb. Our planet operates on a similar principle, known as the planetary dynamo effect. A core of liquid, conductive iron, constantly swirling due to the extreme heat from within, creates a massive magnetic field. This field isn't just invisible lines in a textbook. It's a priceless protective shield that envelops the entire planet, protecting it from the violent storms of space. For about the first 500 million years after its formation, the heart of Mars beat strongly. Its magnetic field at that time was likely even stronger than Earth's is today. Thanks to this magnetic shield, Mars's atmosphere, rich in carbon dioxide and water vapor, was safely protected from the onslaught of the solar wind. Liquid water could flow freely on the surface, and if the first seeds of life existed, they had a safe shelter from dangerous radiation. However, a harsh law of physics began to take hold. Remember the size of Mars. It's only about half the size of Earth and just 10% of its mass. In the universe, size is destiny. A smaller object loses heat much faster than a large one. Imagine you have two bowls of soup, a small cup and a large bowl. The small cup will go cold in just a few minutes, while the large bowl is still steaming. The same was true for Mars. Due to its modest size, the heat stored from its initial formation and from the decay of radioactive elements deep within escaped into space too quickly. As the planet cooled, the liquid iron core began to lose the energy needed to sustain its violent swirls. The decreasing temperature caused the currents of molten metal to slow down, and then, gradually, they stagnated. Imagine the dynamo on the bicycle starting to spin slower and slower, until it no longer has enough power to light the bulb. About 4 billion years ago, the dynamo of Mars began to weaken significantly. The magnetic field, the planet's only protective shield, no longer covered the entire surface, but began to fragment into small, localized patches. Like a fortress whose walls have been torn down, Mars was left exposed and vulnerable to the power of the Sunday. The cooling of the core not only led to the loss of the magnetic field, but it also ended other vital geological activities. As the planet's interior was no longer intensely molten, the convection currents that drive the movement of tectonic plates also stopped. On Earth, the movement of continental plates and continuous volcanic activity help recycle carbon dioxide, keeping the atmosphere in a state of balance. But on Mars, As its heart grew cold, the planet also gradually became geologically dead. Its massive volcanoes no longer received a supply of magma from deep within, and the planet's breath, the outgassing process that replenished the atmosphere, slowly faded away. This event, the stopping of its heart, was a tragic turning point in the history of Mars. It was as if a silent but dedicated guardian had fallen, leaving a beautiful field of flowers unprotected from a great storm. Evidence of this ancient magnetic field is still preserved in the bands of rock in the southern highlands of Mars. When orbiters fly over, they measure faint magnetic signals left in the rocks, like echoes from a distant, glorious past. Now, take a moment to feel the stillness. Deep inside Mars today, the core is still there, but it no longer provides life or protection for the planet. It has become a cold, silent block of metal, and it was this silence that paved the way for an external enemy to invade. With its protective shield shattered, the atmosphere of Mars came face to face with a silent and ruthless thief, one that always lies in wait at the center of the solar system. To understand how the atmosphere was so painfully stripped away, we will need to look up to the sky, where the solar winds are beginning to sweep through. We close this chapter with a deeper understanding of the importance of a planetary core. Without a warm, moving heart, a planet, no matter how perfect its beginning, cannot maintain its beauty against the harshness of space. Continue to breathe deeply, slowly, and feel the safety and warmth of Earth, the fortunate planet that still holds on to its blazing heart. In the next chapter, we will witness the immediate consequences of losing the magnetic field as the invisible shield shatters, leaving a weakened Mars exposed to the power of the cosmos. Let your mind continue to drift in the quiet of space, where the stars twinkle like diamond dust on black velvet. We've just learned about the heart of Mars, the molten metal core that once beat so powerfully. Now, I invite you to imagine something invisible, yet incredibly powerful, a protective shield that any planet wishing to sustain life must have. This is the magnetic field, also known as a planet's magnetosphere. Imagine, 4 billion years ago, Mars was surrounded by a dense network of magnetic field lines, arching gracefully from the South Pole to the North Pole. This shield was invisible to the naked eye, but it enveloped the planet like a safe cocoon, stretching thousands of kilometers into space. It stood there, silent and resilient, to confront the most terrifying storms from the Sunday. Without this shield, the fragile atmosphere that Mars had painstakingly built would be like a house without a roof in a hurricane. In the early days of the solar system, our sun was a rebellious young star. It didn't just radiate light and warmth, it also constantly ejected powerful streams of charged particles, flying at speeds of millions of kilometers per hour. Scientists call this the solar wind. Picture these winds as a torrent of microscopic atomic particles carrying immense energy, ready to blow away anything in their path. When these winds slammed into Mars, they collided with the magnetic shield. Thanks to the power of the dynamo in the planet's core, the shield skillfully deflected these charged particles, forcing them to flow around the planet instead of plowing into its atmosphere. But as we know, Mars's destiny changed when its inner core began to cool. As the flow of molten metal slowed, the magnetic field lines also began to weaken. Imagine the protective cocoon, once as strong as a fortress wall, now starting to show cracks. At first, there were only small holes, but gradually, Mars's global protective shield was torn to shreds. This was a slow and silent process. Instead of a unified magnetic field protecting the entire planet, Mars was now left with only tiny islands of magnetism, scattered in a few places across its rocky crust. Scientists discovered this thanks to the Mars Global Surveyor spacecraft. As it flew over the southern highlands of the Red Planet, the craft detected strange magnetic signals rising from the ancient rock layers. These were magnetic memories locked in the rocks from billions of years ago, like a diary entry that read, "A great shield once stood here." When this invisible shield shattered, the atmosphere of Mars was officially pushed to the front lines. Without protection, gas molecules like carbon dioxide, nitrogen, and especially water vapor came face to face with high-energy particles from the Sunday. These particles acted like tiny bullets, constantly bombarding the uppermost layer of Mars's atmosphere. With each collision, they transferred an enormous amount of energy to the gas molecules, causing them to move so fast that they escaped the planet's weak gravity and flew off into the endless void of space. Try to picture an old house on the seashore. As long as the windbreaks and seawalls remain strong, the house is peaceful. But once the seawall breaks and the trees are cut down, the salty winds and fierce waves will begin to erode every brick, every door, until the house is nothing but a pile of ruins. The same happened to Mars. The loss of its magnetic field was the first shot signaling the collapse of a blue planet. In the silence of space, we can see a somber image. The fragile tendrils of Mars's atmosphere being swept away by the solar wind, stretching into an invisible tail behind the planet, much like the tail of a comet. Every second that passes, Mars loses hundreds of kilograms of its air. Over hundreds of millions of years, this relentless erosion has stripped the red planet of its warm blanket, leaving it barren and cold. The death of the magnetic shield wasn't just a simple physical event. It was the beginning of a chain reaction. As the atmosphere thinned, the pressure dropped, making it impossible for liquid water to remain stable on the surface. The oceans began to evaporate faster, and the water vapor that rose high into the sky was in turn attacked by the solar wind and pushed out into space. A vicious cycle had formed, turning a promising paradise into a deadly desert. As you lie here, feeling the comfort of the space around you, remember how lucky we are. Our Earth still has a hot heart, still maintains a strong magnetic shield to protect our blue sky and vast oceans. The story of Mars is a reminder of the fragility of those ideal conditions. Chapter 5 closes with the image of Mars's shield shattering into a million pieces, leaving the planet naked before the wrath of the stars. We understood why the protective layer disappeared, but how does the real attacker, the solar wind, actually work? How can those invisible winds erode an entire, massive atmosphere? We will learn about this silent thief together in the next chapter. For now, let this feeling of relaxation guide you, your breath slow and deep, like the silence of space between the stars. Everything is becoming lighter than ever before. Let your breath slow down, steady and even, like the pulse of the vast universe. We have just witnessed Mars's magnetic shield shatter, leaving the planet exposed in space. Now, a silent villain emerges from the center of the solar system, beginning its journey to relentlessly steal the red planet's atmosphere over billions of years. That is the solar wind, the most invisible yet ruthless thief in space. To understand this thief, imagine our sun doesn't just radiate gentle light or daytime warmth. In reality, the sun is a giant and chaotic nuclear reactor. From its fiery surface, a cascade of microscopic charged particles, mainly protons and electrons, is constantly blown out into space in every direction. This stream travels at a tremendous speed, often reaching about 1,600,000 to 2 million kilometers per hour. Picture a never-ending storm, sweeping through every corner of the solar system with unshakable power. On Earth, we are fortunate to have a strong magnetic field to deflect this stream, creating the brilliant green auroras at the poles without harming the atmosphere below. But for Mars, with its protective shield gone, the solar wind began to erode the planet in incredibly sophisticated and cruel ways. It didn't arrive like a massive explosion to blow everything away in an instant, but rather like a swift current of water, eroding a pebble, a little bit each day, a little bit each year, but never stopping. Scientists, thanks to NASA's MAVEN spacecraft mission, a modern satellite launched in 2013 to study Mars's atmosphere, have discovered the mechanism of this thief. There are two main ways the solar wind strips Mars of its air. The first is called ionization. When particles from the sun slam into the upper atmosphere, they are like high-energy bullets hitting molecules of carbon dioxide or nitrogen. This collision knocks electrons out of the gas molecules, turning them into charged particles called ions. Once they become ions, they are easily grabbed by the magnetic field inherent in the solar wind itself and pulled away into endless space. The second method is even more interesting and terrifying. Likened by scientists to a game of billiards at the atomic level, called impact evaporation, or more technically, sputtering. Imagine gas molecules in Mars's upper atmosphere floating gently. Suddenly, a heavy particle from the solar wind rushes in at an extremely high speed, colliding head-on with an oxygen or carbon dioxide molecule. The force of the impact is so strong that it transfers all its momentum to the Martian gas molecule, causing it to be knocked out of the planet's gravitational pull like a billiard ball that's been hit hard and flies off the table. And so, with each passing second, Mars loses an amount of gas equivalent to about 100 grams to a few kilograms. You might think this number is tiny compared to a planet, but do a little math in your head. For the past 4 billion years, every second, every minute, every hour without rest, the solar wind thief has persistently done its work. The total amount of stolen gas is large enough to fill a dense ocean of atmosphere, the very thing that once protected and warmed this planet. The Maven spacecraft has sent back precious data, showing that in the past, when the sun was young and much more active than it is now, the rate of atmospheric loss on Mars was many times more severe. There were times when the solar wind blew away Mars's atmosphere tens of times faster than the current rate. This is the explanation for how a planet that once had cloud cover and falling rain could become a desiccated mummy. Imagine you are standing on a high mountain on Mars 3 billion years ago. You can feel the atmosphere thinning with each passing millennium. The once dense water vapor clouds that obscured the sun are now gradually thinning out. The decreasing air pressure causes water in the rivers to begin to boil and evaporate more easily. And as the water vapor rises, it continues to be kidnapped by the solar wind. It was an escape with no way back. The red planet was like a person being stripped of their clothes, layer by layer, in the icy winter of the universe. The cruelty of the solar wind is also shown in how it not only took away carbon dioxide to cool the planet, but it also took away hydrogen, the key component of water. When water molecules are split into hydrogen and oxygen by sunlight, the lightest hydrogen atoms are the first to be swept away by the solar wind. With no hydrogen left, water cannot reform, and Mars permanently lost the ability to recreate its oceans. In the silence of the night, the story of the solar wind reminds us of the power of invisible things. We cannot see the solar wind, cannot feel it on our skin, but its influence can change the fate of an entire world. Mars lost the battle with this silent thief because it lost its magnetic shield too soon. Now, let your mind rest. The image of tiny energy particles flying through distant space will gradually fade, giving way to a feeling of lightness and relaxation. We have learned about the external thief, but Mars has another fatal flaw within itself: its gravity. Why couldn't such a small planet hold on to what belonged to it, even without the solar wind? In the next chapter, we will explore gravity and escape, to see that sometimes being light and modest in size is a sorrow in the harsh universe. For now, relax completely and let your breath guide you into a state of deep peace. Let your body sink even deeper into the stillness, feeling every muscle relax on the soft surface beneath you. In previous chapters, we learned about external attackers like the solar wind and the weakening of the fiery heart deep inside Mars. But tonight, I want to tell you about an internal factor, a characteristic within the very nature of the red planet that quietly aided the departure of its atmosphere and blue oceans. That is gravity, or in other words, the modest pull of a small planet. In the vast universe, every celestial body possesses an invisible embrace to hold everything around it. That embrace is gravity. Imagine gravity as the love of a planetary mother, always trying to keep her children, the gas molecules and water droplets, close by her side. Our Earth is a strong mother with a large body, so its pull is very sturdy, strong enough to hold on to a dense atmosphere for us to breathe. However, Mars is a much smaller and frailer mother. As we know, Mars has a mass of only about 1/10 that of Earth. This modest size leads to an inevitable consequence. The gravitational pull on Mars's surface is only about 38% of our planet's. This means that if you weigh 100 kilograms on Earth, when you set foot on the red dust of Mars, you would feel as light as a feather, weighing only about 38 kilograms. You could easily make towering leaps, feeling as if you were floating in a gentle dream. But that delightful lightness for us was a tragedy for its atmosphere. To understand why weak gravity causes a planet to lose its air, let's imagine a concept called escape velocity. This is the minimum speed an object, or even a tiny gas molecule, needs to achieve to break free from a planet's gravitational pull and fly off into space forever. On Earth, this speed is about 11 kilometers per second, an incredibly high speed that very few gas molecules can naturally reach. But on Mars, because its gravity is so weak, the doorway to space is much wider. A gas molecule only needs to reach a speed of about 5 kilometers per second to say a final goodbye to the red planet. In the atmosphere, gas molecules are never still. They are like tiny dancers in a never-ending party, constantly moving. They collide with each other, exchanging energy and moving at different speeds. The planet's temperature determines how fast these dancers move. The warmer it is, the more vigorously they move. Even at normal temperatures, there are always a few lucky gas molecules that gain enough energy through collisions to reach escape velocity. Because Mars has a low escape velocity, gas molecules in the upper atmosphere, where the air is already thin, are easily flung out into space. This process happens silently, little by little, and is called thermal escape by scientists. The lightest elements are the first to flee. Those are hydrogen and helium. The story of hydrogen is one of the most tragic parts of the disappearance of Mars's oceans. Remember, water is made of oxygen and hydrogen. When ultraviolet light from the sun hits water vapor molecules high in Mars's atmosphere, it breaks this bond, splitting the water into separate hydrogen and oxygen atoms. Since hydrogen is the lightest element in the universe, under Mars's weak gravity, these atoms are like balloons with their strings cut, quickly escaping the planet's grasp and disappearing into the darkness of space. As the hydrogen leaves, it leaves behind lonely oxygen atoms. Some of this oxygen also escapes, but another part returns to the surface, reacting with the iron in the rocks and soil to create the red rust color we see today. And so, over billions of years, Mars couldn't hold on to its precious ingredients. The more gas it lost, the thinner its atmosphere became. The air pressure dropped so low that liquid water could no longer exist stably on the surface. Imagine you're boiling a kettle of water on a high mountaintop. The water will boil and evaporate at a much lower temperature than it would at sea level. On Mars today, the pressure is so low that even if the temperature rises above freezing, water won't flow as a liquid. Instead, it will immediately boil and turn into vapor, beginning its own journey of escape into space, aided by the weak gravity. The small size of Mars isn't just a physical characteristic, it was a sentence of doom. A planet without enough mass doesn't have enough strength to hold onto its warm blanket of an atmosphere. Mars is like a child trying to hold sand in its small hands during a strong wind. No matter how hard the child tries, the grains of sand still slip through their fingers and are blown away. In the stillness of tonight, as you feel the gentle pull of Earth's gravity holding you safely on the ground, take a moment to be thankful for our planet's enormous mass. It is Earth's weight that has held onto every molecule of oxygen you breathe, every drop of water in the oceans that sustains all life. Mars didn't have that good fortune. It was simply too light, and so it became empty. We close this chapter with the image of the last gas molecules silently leaving Mars, flying into the infinite void, leaving behind a world that grows ever thinner and colder. Gravity opened the door for their escape, and the solar wind carried out the theft. But Mars still had one last effort to save itself. That effort came from its giant volcanoes, stone giants that once tried to breathe more life into the atmosphere through violent eruptions. In the next chapter, we will explore the giant volcanoes and the last breath, to see how even the greatest geological efforts couldn't fight against the harsh laws of the universe. For now, let your mind relax completely as your steady breath guides you into the deepest state of peace. In the silence of space, as the rivers began to dry up and the atmosphere was eroded by the solar wind, the red planet still had one last hope to sustain itself. That was the power from deep within the Earth, where stone giants were silently gathering energy. Tonight, we will journey together to learn about the greatest volcanoes in the solar system and their role as the last lungs trying to breathe warm breaths into Mars's atmosphere before everything fell into an eternal sleep. If you could have floated above the Tharsis Plateau on Mars billions of years ago, you would have been stunned by a majestic scene beyond description. There, 4 giant volcanoes reached up to the highest levels of the atmosphere. The most prominent among them is Olympus Mons, a geological wonder that, if placed on Earth, would cover an area nearly the size of France. Olympus Mons is not a sharp, steep mountain like Mount Everest. It's a shield volcano with a gently sloping shape like an ancient warrior's shield laid on the ground. But its greatness lies in the numbers. This mountain is about 25 kilometers high, which is 3 times the height of the tallest mountain on Earth. The diameter of its base is about 600 kilometers. To climb to its summit, a hiker would have to travel hundreds of kilometers up its gentle slopes until they stood at an altitude where the air becomes so thin it nearly touches the black void of space. Why did these volcanoes get so enormous? The answer lies in the very feature we've discussed, the lack of plate tectonics on Mars. On Earth, the planet's crust is always moving, which pushes volcanoes off the hotspots that supply their magma, creating chains of smaller volcanoes. But on Mars, the crust is a stationary block. The volcanoes just stayed in one place for billions of years, receiving wave after wave of molten magma from deep within the planet, building up layer upon layer until they reached an unimaginable size. These volcanoes were the lifeblood of Mars's atmosphere. Every time a volcano erupted, it didn't just pour out rivers of red-hot lava, but also released a huge amount of gases from deep inside the planet. This process is called outgassing. The volcanic breaths carried carbon dioxide, nitrogen, and a large amount of water vapor. It was these violent eruptions that continuously replenished the atmosphere, being stolen by the solar wind above. For hundreds of millions of years, volcanic activity helped Mars maintain an atmosphere thick enough to keep the planet warm and allow liquid water to exist. Imagine a time when Mars was on the borderline between life and death. The ruthless solar wind stripped away the air in the upper atmosphere, but below, the churning lava flows from Olympus Mons tirelessly pumped more vitality into the sky. It was a prolonged battle between the destructive forces of space and the creative forces from within the planet. As long as the volcanoes were active, Mars still had a chance to hold on to the blue of its oceans. But, as is the harsh rule of nature, all energy sources eventually run out. As we already know, the heart of Mars, its molten iron core, cooled down quickly due to the planet's small size. As the planet's interior grew cold, the enormous heat source needed to melt rock into magma also gradually vanished. The convection currents beneath the Martian crust slowed down and then stopped completely. About 1 billion years ago, or perhaps even earlier, the last eruptions on Olympus Mons took place. The final lava flows cooled and hardened into layers of dark rock. Smoke, dust, and gases were no longer released into the sky. The lungs of Mars had officially stopped breathing. From that moment on, the red planet had no way to replace the atmospheric gas that was being lost every single day. The silence of the volcanoes was the final nail in the coffin for a warm Mars. With no new carbon dioxide being added, the greenhouse effect on the planet began to weaken dramatically. The temperature started to plummet, and the already fragile atmosphere became even thinner, with no protection from within. Mars gradually transformed into a world of rock and dust, where the stone giants were only silent monuments to a glorious past. Scientists, using sharp images from orbiters from NASA and the European Space Agency, or ESA, have carefully studied the lava flows on the slopes of Olympus Mons. They discovered that some lava flows look very new, possibly having formed only about 20 million years ago, a very small number compared to the planet's age. This shows that Mars tried to fight until the very last moments, managing to push out its weakest breaths before falling completely into a cold slumber. Now, as you lie in the peace of the night, try to imagine Olympus Mons, a giant sleeping in the middle of the red desert. That mountain was once a symbol of Mars's revitalizing power, but now it stands there, lonely and silent beneath a starry sky. It reminds us that even the most majestic entities must submit to the flow of time and the harshness of the universe. The cessation of volcanic activity not only caused the atmosphere to be lost, but also led to another frightening consequence. The cold began to invade, trapping the remaining gases within the rock. This is a phenomenon that scientists call the reverse greenhouse effect. When the planet was no longer being warmed, its very own atmosphere began to turn against it. Chapter 8 ends with a silence that blankets the highest peaks of Mars. We have seen the great power of volcanoes and the sorrow of their extinction. In the next chapter, we will explore the reverse greenhouse effect to understand why Mars became so cold that even its atmosphere had to freeze. For now, let this tranquility guide you into a state of perfect rest, where all the sounds of the world fade away, leaving only the steady rhythm of your own breath. In the enveloping silence of the night, as we've journeyed through the highs and lows of Martian history, from its rushing rivers to its majestic, dormant volcanoes, one question has always lingered in the void. Why did this planet's atmosphere not only get stripped away by the solar wind, but also seem to disappear into the ground itself? Tonight, we will learn about a silent but powerful phenomenon that turned Mars into an eternal icebox, the reverse greenhouse effect. To begin, imagine a planet's atmosphere as a warm blanket, wrapping it against the coldness of space. On Earth, this blanket is made of many gases, the most important of which are carbon dioxide and water vapor. These gases have a special ability. They allow sunlight to pass through to warm the ground, but they trap that heat, preventing it from escaping back into space. Thanks to this natural greenhouse effect, our planet maintains a temperate climate where life can sprout and flourish. 4 billion years ago, Mars also possessed such a thick blanket. Its atmosphere, rich in carbon dioxide, created high pressure and kept the planet warm, even when the sun at that time was still quite faint. But then, liquid water, the very thing we cherish, unwittingly became part of the process that stripped that blanket away. Picture the ancient rains falling on the surface of Mars. As the raindrops fell through the atmosphere, they dissolved a large amount of carbon dioxide, forming a weak acid. When this water flowed over the surface and seeped deep into rock layers rich in silicon, calcium, and magnesium, a slow but persistent chemical reaction occurred. Instead of remaining in the air to warm the planet, the carbon dioxide became locked away into rock minerals, forming sturdy carbonate rocks. Scientists call this process chemical weathering. On Earth, we have this process too, but we have a fantastic recycling mechanism. Earth's tectonic plates are constantly moving, carrying these carbon dioxide-containing rock layers deep into the molten interior. Then, volcanoes erupt and release that gas back into the atmosphere. It's a perfect cycle. But Mars, as we know, is a planet with a quiet crust and a cooling core. Once the carbon dioxide was locked into rock, it had no way to return. Mars has no recycling, and so its warm blanket grew thinner with each millennium. As the amount of heat-trapping gas in the atmosphere decreased, a grim feedback loop began. The planet started to cool, and when the temperature dropped to a certain threshold, the water vapor in the air began to condense and freeze, turning into a blanket of white snow covering the ground. Water in its ice state is not as good at retaining heat as water vapor, and the white color of the ice and snow reflects sunlight back into space, making the planet even colder. This is when the reverse greenhouse effect pushed Mars into an abyss of ice. When the temperature dropped to extreme lows, even the remaining carbon dioxide in the air could not maintain its gaseous state. At the poles of Mars, the temperature dropped below -125 degrees Celsius. At this frigid point, carbon dioxide began to freeze solid into dry ice and fall to the surface. Imagine a silent landscape on Mars during that era. Instead of refreshing rain, the planet received snowfalls of dry carbon dioxide. The more gas that froze into rock and snow, the thinner the atmosphere became. The warming blanket was now so tattered and fragile that it could no longer hold onto any warmth. The atmospheric pressure plummeted, causing any remaining liquid water on the surface to quickly freeze or evaporate into nothing. Modern rovers like NASA's Curiosity and Perseverance have found clear evidence of this process. By drilling deep into ancient impact craters, they've discovered the presence of carbonate and clay minerals, the prisons that have held Mars's atmosphere captive for billions of years. It is a cruel irony of nature. The very conditions necessary for water and early life contributed to the collapse of the entire planet's climate system. Today, Mars stands as a lesson in fragile balance. If a planet is too small, it won't have enough internal heat to maintain its atmospheric cycle. Once chemical reactions start removing greenhouse gases without replenishment from volcanoes, that planet will fall into a cold trap with no escape. Mars could not fight against the law of geological silence. As you lie here, feel the warmth of the air around you. This is thanks to the persistent activity of Earth's interior, which is still continuously recycling and supplying the gases needed to sustain life. Mars lost that good fortune a long time ago. That planet is now just a world whose breath has been fossilized in rock and frozen at its poles. The disappearance of the atmosphere and the bone-chilling cold led to an inevitable fate for its blue oceans. Water couldn't just magically disappear completely. It had to go somewhere. Did all the water on Mars escape into space, or is a large amount still hiding somewhere we haven't yet seen? Chapter 9 closes with the image of a planet shivering in a bleak cloak of dry ice. We have understood how the thermal trap ensnared Mars. In the next chapter, we will undertake a great investigation together, the search for the lost ocean. We will follow the last traces of water to see if they are on the run or lying dormant beneath the red dust. Now, completely relax your fingers and toes, feeling a sense of lightness spreading. Your breath is steady and slow, bringing you into the most relaxed state. All the mysteries of the universe will await us in the next chapter. In the absolute stillness of the night, as your breathing has become steady and your mind is ready for distant dreams, join me in conducting the greatest investigation in the history of astronomy. We know that Mars was once a blue planet, with vast oceans covering a third of its surface. But now, looking at the reality, the planet is just a dry, red desert. So, where did that enormous amount of water go? Did it vanish into nothingness? Or is it still hiding somewhere, waiting to be awakened? Imagine you are a cosmic detective, standing at an empty crime scene. The dry riverbeds and arid deltas are evidence that the victim to the oceans was once here. Scientists estimate that the amount of water that once existed on Mars was enough to form an ocean covering the entire planet, with an average depth of up to hundreds of meters, and even over 1,000 meters in some areas. That is a colossal volume of water, equivalent to trillions upon trillions of liters. The first clue leads us high into the sky. As we learned in previous chapters, the solar wind has relentlessly bombarded Mars's thin atmosphere. When ultraviolet light split water molecules into hydrogen and oxygen, the lightest hydrogen atoms permanently left the planet, escaping into space. Scientists use powerful telescopes to measure the ratio of different forms of hydrogen in Mars's current atmosphere. They've found that the amount of heavy hydrogen, a rarer form that has more trouble escaping, is now very high. This proves that an enormous amount of water has indeed evaporated and disappeared into the cosmos over billions of years. However, the escape route into the sky cannot explain the entire disappearance of the oceans. A large portion of that water must still be somewhere closer to home. And the second clue leads us to the two poles of the red planet. Beneath the layer of dry ice made from carbon dioxide that we often see, there are layers of real water ice, kilometers thick. If we could melt all the ice at the south pole of Mars, the water would be enough to cover the entire planet's surface in a layer of water 11 meters deep. Although immense, this number is still only a fraction of the great oceans of the past. So where is the rest of it? The answer might be right beneath our feet, deep within the planet's rock. The third clue leads us to hydrated minerals. As water flowed through rock layers billions of years ago, it participated in chemical reactions and became locked inside the structure of minerals like clay or gypsum. Instead of flowing as a liquid, the water became part of the rock itself. Some of the latest research suggests that as much as 30 to 90% of Mars's ancient water could have been trapped in the planet's crust this way. Mars didn't so much lose its water as it swallowed its own oceans into the ground. But the mystery doesn't stop there. The fourth clue, and the most thrilling, has just been revealed through seismic data from NASA's InSight lander. By listening to the deep rumbles within the planet, scientists have found evidence of a huge treasure trove of liquid water deep beneath Mars's crust. Not just a few feet or a few hundred feet, but at a depth of about 11.5 to 20 kilometers. There, water may be weaving through the cracks of ancient granite. This groundwater reserve is predicted to be so vast that it could fill all of Mars's ancient oceans. Imagine a dark and silent subterranean world where water droplets from 4 billion years ago still exist quietly, protected from the harsh solar wind and the bone-chilling cold of the surface. It's a forgotten ocean, lying so deep that we can't yet reach it with any current drilling technology. The existence of this water brings intense hope. If there's liquid water, could tiny life forms be sheltering in that profound depth? The search for the lost ocean has taken us from the upper layers of the atmosphere, across the stark white permanent ice caps, all the way to the deepest layers of rock. We realize that Mars didn't simply lose its treasure. The planet underwent a painful transformation, where its water was torn away by the cosmos, frozen by the cold, and buried by its own rock and soil. Water on Mars today exists in three quiet forms: a little fragile moisture in the air, rock-hard ice at the two poles, and a massive amount of liquid water sleeping deep underground. The presence of water in any form is a promise for the future, a crucial clue for humanity to dream of one day setting foot there and reviving this planet. As you lie here, feeling the comfort spreading through your body, imagine those ancient water droplets lying dormant deep beneath the red dust. They are like distant memories. Though obscured by time, they have never truly disappeared. The world of Mars is a reminder that a planet's greatest treasure sometimes isn't found in its brilliant exterior, but is hidden in the quietest, most profound places. We close this investigation into the lost oceans with a sense of relief. The water is still there, in one form or another. To better understand how scientists have meticulously pieced this puzzle together, we'll need the help of a special detective orbiting Mars. That is the MAVEN mission, the spacecraft that completely changed how we see the red planet's atmosphere. In the next chapter, we will learn about the mission's groundbreaking discoveries. For now, let the silence envelop you, your breath becoming as steady and gentle as the deep subterranean waves within Mars. Everything is becoming hazy, giving way to a state of absolute relaxation. Let your mind continue to wander among the stars, where vast space cradles your sleep with absolute silence. We have journeyed far to learn about Mars's losses, from its cold core to its buried oceans. But how can humans, from millions of kilometers away, know exactly what is happening to the red planet's atmosphere? Tonight, I will introduce you to a silent detective working tirelessly in Mars's orbit, the MAVEN mission. MAVEN is an English acronym for a very long phrase, which means Mars Atmosphere and Volatile Evolution Mission. This spacecraft was launched by NASA in November of 2013, and after a long 10-month journey through the blackness of space, it entered Mars's orbit in September of 2014. Since then, MAVEN has become humanity's eyes and ears, helping us decode the mystery of where Mars's atmosphere has gone. Imagine MAVEN as a great albatross soaring through the highest levels of the Martian sky. Instead of looking down at the ground for dried-up rivers, MAVEN aims its sophisticated instruments towards space and at the thin, remaining layers of air. It doesn't just stay in one place. It performs spectacular deep dips, lowering its altitude to only about 150 kilometers above the surface to directly taste and smell the gas molecules in the upper atmosphere. The most important discovery MAVEN has brought us is the identification of the planet's real thief. Through extremely precise measurements, scientists have witnessed in real time how the solar wind strips away Mars's atmosphere. MAVEN has measured that, on average, Mars loses about 100 grams of air to space every second. Just imagine, every second, an amount of gas equivalent to the weight of a large apple is blown away forever. This number might sound small for an entire planet, but over billions of years, it's the very reason Mars's sky became so empty. But the story doesn't just stop at steady erosion. MAVEN also discovered an even more astonishing truth when it observed the sun's fits of rage. When a powerful solar storm hits, the rate of atmospheric loss from Mars is no longer 100 grams. It skyrockets to 10 or even 20 times the normal rate. High-energy particles from the sun sweep past Mars like a powerful gust, whisking away oxygen, carbon dioxide, and hydrogen molecules for millions of kilometers. This indicates that in the distant past, when the sun was younger and much more volatile than it is now, Mars's atmosphere was stripped clean at a terrifying rate. MAVEN also helped us better understand the ways in which these gases escape. Some molecules are pushed out in a straight line, but there are also streams of gas that get swept away in a long plume, forming a giant magnetic tail behind the planet, much like the tail of an invisible comet. Thanks to its spectrometer, MAVEN has seen faint clouds of hydrogen and oxygen leaking from Mars, creating a dim halo around the planet that is invisible to the naked eye. Another interesting thing this detective discovered is Mars's seasonal changes. In the summer, when the planet's surface is warmer, enormous dust storms can push water vapor higher into the atmosphere. There, the water vapor is easily broken apart by sunlight and carried away by the solar wind. Therefore, Maven has proven that Mars is still continuing to lose water and air every day, albeit at a slower rate than billions of years ago. The data from Maven is like the final pieces of a giant puzzle. It allows scientists to turn back time, simulating Mars's atmosphere from 4 billion years ago. The result is astonishing. Mars once had a thick atmosphere, at least as dense as Earth's today, with enough pressure to sustain rushing rivers and lapping oceans. As you lie here, feel the peace of a windless night. In a distant place, Maven is still quietly circling the red planet, sending back tiny radio signals that hold the secrets of the universe. It reminds us that to understand a planet, we sometimes have to look not just at what it has, but also at what it has lost, and how the cosmos has shaped its destiny. The Maven mission has answered the question of how and when Mars's atmosphere disappeared. It confirms that this loss is a continuous and irreversible process without external intervention. These answers from orbit have helped us better understand the fragility of life and the importance of the protective shield that Earth possesses. Chapter 11 closes with the image of the small spacecraft gliding between darkness and light, persistent and resilient. We have obtained solid scientific answers. But in the differences between Mars, Earth, and their other sibling, Venus, there are still fascinating lessons waiting to be learned. Why did three planets with similar beginnings end up with completely different fates? In the next chapter, we will undertake a grand comparison of these three worlds to see the miraculous design of the cosmos. Now, let your mind relax completely as your steady breath guides you into the deepest state of peace, where all questions are soothed by the silence of the dark night. In the quiet stillness of the late night, let your mind gently soar, moving beyond the boundaries of Mars to look back at the grand family of rocky planets in our solar system. We often wonder, why did these three closest siblings, Venus, Earth, and Mars, have such different fates? Why did one become a scorching furnace, another a paradise for life, and the third a frozen desert? Tonight, we will seek the answers together through a grand comparison of these three worlds. Imagine the dawn of the solar system, more than 4 billion years ago. Back then, all three of these planets looked very similar. All three were scorching hot rocky spheres, enveloped in thick atmospheres with water flowing on their surfaces. They were like three seeds sown in the same cosmic soil, but differences in their location and size led them down three completely opposite paths. First, let's visit Earth's sister planet, Venus. Venus is nearly identical to our planet in size and mass, but it's about 40 million kilometers closer to the Sun. This proximity is the source of all its tragedy. On Venus, the initial temperature was already higher, causing water to evaporate intensely. Water vapor is an extremely effective greenhouse gas. It trapped heat from the sun and made the planet even hotter. A terrible feedback loop occurred. The hotter it got, the more water evaporated, and the more water vapor there was, the hotter the planet became. Eventually, all the oceans on Venus boiled away and escaped into space. With no water left to absorb carbon dioxide into the rocks, this gas accumulated in the sky to a terrifying density. Today, Venus is shrouded in a thick atmosphere 90 times denser than Earth's, with a surface temperature of over 460 degrees Celsius, hot enough to melt lead. It was a runaway greenhouse effect, turning the planet into a true hell. At the other extreme, we look to Mars, the small, youngest sibling. Mars is the farthest of the three from the Sun and is only half the size of Earth. As we've learned, its small size was precisely why Mars couldn't retain its internal heat. Its heart cooled too quickly, causing it to lose its protective magnetic shield. Without this shield, the solar wind stripped away its atmosphere. And without an atmosphere, the planet fell into a permanent, deep freeze. If Venus is a blazing furnace, then Mars is a barren, airless icebox. Two opposite fates, but both leading to an uninhabitable harshness. And then, let's look at our home, Earth. We are fortunate to be in a just right position, not too close to be scorched like Venus, nor too far to be frozen like Mars. But location isn't everything. Earth was lucky to be large enough to maintain its internal heat for billions of years. Our molten iron heart is still spinning, generating a powerful magnetic field that protects our blue sky. Earth also has a marvelous self-regulating mechanism through the movement of its tectonic plates. When there's too much carbon dioxide, it dissolves into the oceans and gets locked into rocks. Then, thanks to volcanic eruptions, just enough of the gas is returned to the sky to keep us warm. This is a perfect cycle that neither Venus nor Mars possesses. The differences between the three planets can be summarized by three factors: distance from the Sun, the planet's size, and its geological activity. Venus was too hot to keep its water. Mars was too small to keep its air, while Earth had all the ideal factors. This comparison truly shows us how fragile and precious our own planet is. Earth is like a peaceful oasis, situated between two of the universe's harsh extremes. Picture these three planets as three travelers on the road of time. The traveler Venus wore too many coats and suffocated in its own heat. The traveler Mars dropped its only coat and shivered in the bone-chilling cold of space. Only the traveler Earth knew how to adjust its clothing to always feel comfortable. Scientists often call the region of space where Earth is located the Goldilocks zone, named after the little girl in the fairy tale who chose the porridge that was not too hot and not too cold. However, through the stories of Mars and Venus, we understand that this zone is not fixed. If we don't know how to protect our atmosphere, Earth could very well slide toward one of those two sad endings. Mars is a lesson about losing protection from within, while Venus is a lesson about losing control over greenhouse gas emissions. Whenever you look up at the night sky and see Venus glittering like a diamond or Mars glowing red like an ember, remember that they are mirrors reflecting different scenarios of planetary history. They remind us of our good fortune and the responsibility we have to preserve this precious atmosphere. Now, as this comparison comes to a close, you can feel the warmth of Earth embracing you, the air you're breathing, the gentle oxygen entering your lungs. It's all the result of a miraculous balancing act that has lasted for billions of years. Mars once had that chance, but it let it slip away. The loss of Mars's atmosphere didn't just leave behind a rocky desert, it also left behind humanity's biggest question. In its lush, golden age, did life ever have a chance to sprout? We close chapter 12 with a deep appreciation for our blue planet. In the next chapter, we will delve deeper into the mysteries of biology on the red planet. Did life ever exist? We will explore whether tiny microorganisms ever swam in the lost oceans of Mars. Now, let your body relax completely, feeling the absolute safety beneath Earth's magnetic shield. Your breathing is slow and steady, carrying you into the deepest, most peaceful sleep. In the quiet of the dark night, as stories of lost oceans and a stripped atmosphere still echo, a profound and lingering question arises in our minds. Did life ever take root on that red planet? In its billions of years of tumultuous history, did any tiny creatures ever call the rivers and lakes of Mars their home? Tonight, we will follow the faintest of clues to find the answer to this great mystery. Imagine Mars 4 billion years ago. It was a warm world with rainfall and rushing rivers. Scientists believe that, at that time, Mars had all three core ingredients to create life as we know it. The first ingredient was liquid water, the magical solvent for all of life's chemical reactions. The second was energy sources, from the gentle light of the sun to the heat radiating from volcanically warmed hot springs. And the third, equally important, was the necessary chemical elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The search for life on Mars doesn't begin with finding little green men, but with tiny grains of dust and chemical molecules. One of the most important milestones was the Curiosity rover's mission in Gale Crater. There, this resilient robot drilled deep into ancient sedimentary rock layers and found complex organic compounds. Carbon, the foundation of all life on Earth, was found in rock samples over 3 billion years old. The presence of these organic molecules doesn't definitively prove that there was life, but it does prove that the raw materials for building life were available there. Let's go deeper into Gale Crater with me. Billions of years ago, this was a large freshwater lake with a neutral pH, not too acidic and not too alkaline, a perfect environment for microorganisms to thrive. Curiosity also found sulfur, nitrogen, hydrogen, and oxygen minerals in chemical states that microorganisms could use as an energy source. This means that if we could take a type of bacteria from Earth back in time to this lake, it could absolutely have flourished. Another fascinating mystery is the appearance of methane gas on Mars. On Earth, most of the methane in the atmosphere is produced by living organisms, from bacteria in animal stomachs to organic decomposition processes. Orbiters and the Curiosity rover have repeatedly detected unusual plumes of methane gas rising from the Martian ground. Why does methane appear and then disappear? Is it the result of chemical reactions between rock and groundwater, or is it the faint breath of dormant microorganisms deep beneath the red dust? This question is still awaiting a satisfactory answer from future missions. In 2021, NASA's Perseverance rover landed in Jezero Crater, once the site of a majestic river delta that flowed into a large lake. Perseverance's mission is very special. It's searching for biosignatures, that is, microscopic fossils or shapes of ancient bacteria preserved in rock. The fine sediment layers here are like a stone diary, capable of preserving the most delicate structures of life from billions of years ago. Perseverance is currently hard at work collecting the most precious rock cores, sealing them in metal tubes to await another spacecraft to pick them up and bring them back to Earth in the future. There is another bold theory that suggests life on Earth may have actually originated on Mars. In its primordial stage, as Mars cooled down faster and became habitable sooner than Earth, the first microorganisms could have formed on the red planet. Then, cataclysmic meteorite impacts could have blasted bacteria-laden rocks into space. These rocks, after wandering for millions of years, fell to Earth like seeds of life. If this is true, then we, the humans standing here, could be the distant descendants of ancient Martians. However, we must also face a harsh reality. Even if life once sprouted, it would have faced a hopeless struggle for survival as the atmosphere and water gradually disappeared. When its magnetic shield collapsed and the solar wind swept across it, the surface of Mars was bombarded by toxic ultraviolet radiation and cosmic rays. Liquid water on the surface became scarce and eventually vanished completely. If life still exists today, it has surely retreated deep underground, where there is warmth from the planet's interior and shelter from the deadly radiation beneath thick layers of rock. The search for life on Mars isn't just about satisfying our curiosity about another planet. It is a journey for us to understand ourselves and our place in the universe. If life could form independently on two neighboring planets, it would mean that this universe is teeming with life. But if Mars, with all its ideal initial conditions, remains a dead planet, we would realize just how miraculous and precious life on Earth truly is. Imagine, one day, a young astronaut picks up a rock on Mars and sees, under a microscope, the image of a simple, fossilized cell. That moment would change the entire history of humanity. It would be an affirmation that we are not alone, and that life is a resilient force, always seeking to arise even in the harshest conditions. This chapter closes with the image of the silent Jezero crater under the blue Martian twilight. The robots are still working quietly, the rock core samples still lying in wait beneath the red sand. The mystery of life on Mars is like a beautiful dream that is slowly being unveiled, bit by bit, with every step of scientific progress. Let your body relax. Feel the comfort that envelops you. The story of ancient life has taken us far, but the journey isn't over. Now that Mars has become a cold desert, what can humans do to change its destiny? Can we bring green back to this planet? In the next chapter, we will step into a grand dream of the future, the dream of a green Mars, climate terraforming. We will explore whether human technology is powerful enough to revive a dead planet. For now, let this tranquility guide you, as your steady breath leads you into the deepest state of peace. In the stillness of the deep night, after we have journeyed together through the tragic ups and downs of the red planet, from its glorious dawn to its decline into a frozen desert, let your mind open to a new horizon. Tonight, we will not just look to the past, but we will dream together of a distant future where human hands and intellect can perform a miracle, reviving a dead planet. This is the concept of terraforming, a grand dream to turn Mars into a second, lush green home for humanity. Imagine, 1,000 years from now, our descendants look up at the sky and no longer see a mournful red dot, but a blue-green planet with wisps of white clouds. To achieve that dream, we must solve the core issues that Mars has faced for billions of years. We must warm the planet, rebuild its atmosphere, and most importantly, create a protective shield so that those efforts are not blown away by the solar wind once again. The first and most crucial step in this grand plan is to warm the planet. Ironically, the very thing we fear on Earth, the greenhouse effect, is the key to saving Mars. Scientists have proposed bold ideas, such as building giant factories on the Martian surface solely to produce super greenhouse gases. These gases have the ability to trap heat thousands of times more effectively than carbon dioxide. As the concentration of these gases increases, the surface temperature of Mars will begin to creep up from its current negative hundreds of degrees Celsius. Another, rather romantic, idea is to use giant mirrors made of ultralight thin film floating in orbit. These mirrors, hundreds of kilometers wide, would focus sunlight onto the polar ice caps of Mars. The heat from these concentrated sunbeams would melt the permafrost. Then, billions of tons of carbon dioxide trapped as dry ice would sublimate, flooding the air, creating a thicker atmosphere that would, in turn, accelerate the planet's warming. It's a positive feedback loop. The warmer the planet gets, the thicker the atmosphere becomes, and the thicker the atmosphere, the warmer the planet gets. But how can we protect this new atmosphere from being eroded by the solar wind? Scientists at NASA have proposed a revolutionary solution, creating an artificial magnetic field. Instead of trying to restart Mars's cold core, we could place a giant magnetosphere generator at a special point in space between the Sun and Mars. This device would generate a magnetic shield, deflecting the stream of charged particles from the Sun, allowing Mars to rest safely in a magnetic wake. Once this shield is in place, the atmosphere we worked so hard to build would no longer be stolen away. Once the atmosphere is thick enough and the temperature has risen above freezing, the real miracle of life will begin. We won't plant trees right away, but we will start with the hardiest organisms. Specialized bacteria and mosses will be introduced to Mars first. They will begin the process of photosynthesis, absorbing carbon dioxide and releasing oxygen. Over centuries, the vibrant red rock and soil will begin to be covered in a pale green hue. Water from underground and from the poles will melt, flowing through ancient valleys, filling the lakes that dried up billions of years ago. Try to imagine the feeling of the first people breathing the Martian air without a helmet. It would be a cool air, carrying the scent of damp earth and the fragrance of new life. Pine forests would begin to grow on the slopes of volcanoes, and real rain would fall after billions of years of waiting. Mars would then no longer be a strange world, but a promised land, a testament to the power of human will against the vast universe. However, terraforming a planet is not the work of one generation. It is a symphony lasting hundreds, even thousands of years. It requires the unity of all humankind and enormous resources that we are only now beginning to imagine. There are those who argue we should leave Mars in its current pristine, wild beauty. But there are also those who believe it is humanity's mission to spread the seeds of green life throughout the universe. As you lie here, feeling the gentleness of sleep approaching, let the dream of a green Mars soothe your mind. That dream is not just about science or technology, but about hope. It shows us that even though a planet can lose everything due to the harsh laws of physics, with wisdom and compassion, humans can restore what was lost. Mars is a reminder of the past, but also a beacon for the future. Chapter 14 closes with the image of a tiny sprout pushing its way up through the red soil of Mars, under a sky that is beginning to turn a bluish hue. We have gone from the sorrow of loss to the faith of rebirth. Our journey to explore the red planet is nearing its final pages. To conclude, we need to look back at the lessons Mars has taught humanity and what they mean for the future of our own beloved Earth. In the final chapter, we will summarize this entire journey and listen to the message from our red neighbor. For now, let your breath be light and deep, feeling the sense of calm spreading from the top of your head to the tips of your toes. Everything is becoming hazy and unusually peaceful. The night is late, and the space around you must now be completely enveloped in a gentle silence. We have journeyed together on a long path, crossing billions of years of history and millions of kilometers of space to understand the fate of the red planet. From its glorious early days with vast blue oceans to its current state as a frozen desert, the story of Mars is not just a lesson in astronomy, but also a profound message for each of us, the inhabitants of this green planet. Tonight, in the final chapter of our journey on the Knowledge Before Sleep channel, we will pause to reflect on the precious lessons Mars has left for humanity. The first and most important lesson Mars teaches us is the fragility of ideal conditions. Before learning about Mars, we often took the air we breathe, the water we drink, and the warmth of the sun for granted, just like our own breath. But Mars has shown us that for a planet to sustain life, a perfect and delicate balance of many factors is required. Just a small change in a planet's size, a premature cooling of its metallic core, or the collapse of its invisible magnetic shield, and an entire paradise can fall apart and disappear forever. Mars once had it all, but it lost everything due to the unforgiving laws of the universe. When we look at Mars, it's like we're looking into a mirror, reflecting the future or the past of other planets. It reminds us of the infinite value of Earth's heart. We are so lucky to be living on a planet where a liquid iron core is still churning powerfully, creating a strong magnetic field to protect us from the relentless storms of solar wind. Without that shield, our sky would also be eroded, our oceans would evaporate, and Earth would be nothing more than a dry husk in space. The lesson from Mars helps us to cherish every cool breeze, every rain shower, and every warm sunbeam, because we understand that they are the result of a magical balance not every planet is fortunate enough to have. Mars also leaves humanity with a cautionary tale about atmospheres and heat-trapping gases. We've seen how a reverse greenhouse effect locked carbon dioxide away in rock and froze the entire red planet. Conversely, on its sister planet Venus, an extreme greenhouse effect has scorched everything. Earth lies between these two extremes, in a delicate balance. The story of Mars reminds us that our atmosphere is a precious but also very vulnerable asset. Although the changes on Mars occurred naturally over billions of years, it shows us the importance of maintaining a stable atmospheric composition. Understanding how Mars lost its atmosphere gives scientists at NASA and other organizations more data to protect our own atmosphere from the climate change that is currently happening. More than just lessons in physics, Mars also teaches us about human persistence and curiosity. Dozens of missions, from the first small spacecraft to modern robotic rovers like Perseverance or Curiosity, are all testaments to humanity's limitless thirst for knowledge. We don't just see Mars as a dead planet, but as a great history book containing the secrets of our own origins. The search for life on Mars, or the dream of one day terraforming this planet and turning it green, helps humanity overcome its own narrow limitations and reach for a more expansive future among the stars. Mars teaches us that we are not separate entities from the cosmos. Our destiny is tied to the destiny of the planets and the stars. When we understand why Mars lost its atmosphere and oceans, we also gain a deeper understanding of our own place in the solar system. It is a position of great fortune, but also of great responsibility. That responsibility is not just to protect our current home, but also to prepare for humanity's first steps onto new worlds. Imagine an evening in the future, when humans have truly settled on Mars. The children born on the red planet will look up at the sky and see Earth as a sparkling blue dot, a distant paradise that their ancestors once worked together to protect. At that time, the story of how Mars lost its atmosphere will become a foundational lesson for every generation, so they understand that life is a miracle to be cherished with all their love and wisdom. Our 15-chapter journey has now reached its final moments. We started from the dusty deserts of the present, traveled back to a brilliant dawn, witnessed the power of volcanoes, the cruelty of the solar wind, and the silence of buried oceans. We also dreamed together of a future where the color green will return to the red planet. Hopefully, this knowledge has given you a fresh, gentle, and inspiring perspective on the vast universe. Now, as the final pages of the story of Mars come to a close, let your mind completely relax. The images of stars, of the magnetic shield, or of ancient rivers will gradually fade, giving way to a deep peace within your soul. You are lying in the warm embrace of Earth, protected by a gentle atmosphere and a steady gravitational pull. There is nothing left to worry about, nothing to rush. Thank you for joining Knowledge Before Sleep on this amazing journey. Take a deep breath and feel a sense of lightness spread throughout your body, from the top of your head down to your very toes. The Earth is still spinning, the stars are still twinkling, and Mars is still there, like a silent old friend, telling us the eternal lessons of time. Everything has come to a complete and peaceful close. I wish you a deep and restful sleep, and may you have beautiful dreams of new horizons in the vast galaxy. Goodbye, and sleep well.